Hey, this is Backseat Physics, and welcome back to another physics video. Today we're doing Unit 3, Section 1, Forces and Laws of Motion Review. Today's Halloween, so happy Halloween for anyone who's watching this on Halloween. And it's also 1 a.m., so if I'm making any silly mistakes, I do apologize. And as always, there is a link to the PDF of all my work in the description below. And on my website, which will also be in the description. You guys should go check that out. Anyways, let's get right into it with question number 1. This is a logic question. If only one force acts on an object, can it be at equilibrium? Explain. Well, worst comes to worst, we can always just make a free body diagram. There we go. So let's just say there's one force being applied that way, and no force on this way. The opposite direction, my apologies. So, as you can see, if there's only one force acting on it, it's non-equilibrium, as there's nothing acting in the other direction. So, no, it cannot be in equilibrium. There we go. There's one question down. Let's go to question 2. Question 2. Consider velocity versus time graph shown. List the intervals that fit each description. So here I try recreating the graph. I should provide it in the question below. Okay, question A. A constant non-zero force is being applied to the object. So we know that there's a force being applied when the graph is moving. So that's right here. It's also right here. And that's right here. Now, it's asking for a constant force, meaning it has a uniform slope. So that means we can count out number 4 as it's not constant. And we also can mark out this straight line middle because that is there's no force on there. It would be a 0 force. So that means number 1 and number 2 is the correct answer for part A. Let me get rid of all of these circles. And now part B. A non-zero force acts in a direction the object is moving. So, when velocity decreases, so to better explain this, so let's say this is a point of origin. Velocity will increase when the object moves away from the origin, and velocity will decrease when it goes towards the origin. So now we have to look for where velocity is increasing. That would be right here and right here. So the answers for part B is 1 and 4. As number 2, we're actually getting closer to the origin. And number 3, the force there again is 0 because there is no slope. Alright, now let's move on to part C. Part C says the net force on the object is 0. Now, as we've been saying, the middle line is not moving at all, meaning that the net force is 0. And then part D says a variable force is applied to the object. A variable force means that it is increasing, or we could say that it's like increasing exponentially, which would be part D, as we could see, is like a parabola, meaning it is increasing exponentially. There we go. That's number 2 for you. Alright, question 3 says, 2 forces acting on a block that is initially at rest on a frictionless surface. Rank the speed after 3 seconds. Explain your reasoning. So, I'll just start off with the answer and explain. So the answer is that block B, is equal to block C, which is greater than A, which is, okay, why are you not working? Which is greater than D. So now, B and C are both the greatest because I'm going to draw out a free body diagram. I'm only going to draw one because they're practically the same. They both have a block that has 2 kilograms, and they both have forces that include 8 and 6, meaning the net force of the object, actually we'll do it like this. So we do force 1 minus force 2 is equal to ma. So 8 minus 6, so 2 is equal to the mass of 2a. Divided by 2. Okay, I don't know why this is being so annoying right now. I tried adjusting the settings, and they don't seem to be working very well. I do apologize. So for block B and C, the acceleration is 1. So now for block A, we have the same amount of force, 6 and 8. I'm not going to write it out again. So we could do 8 minus 6 is equal to 4a, because the block weight is 4, meaning the net force is 2, the mass is 4, so we divide both sides by 4, acceleration is 0.5. That is why it is less than B and C. And then finally for block D, the net force of the object is 0 because it has 10 newtons for left minus 10 newtons for right, which gives you a net force of 0. Alright, and that's question 3 for you. Question 4. Cart A has a mass of 20 kilograms and rolls down a hill at constant speed of 10 meters per second. Cart B has a mass of 10 kilograms and rolls down at a constant speed of 30 milliseconds. Compare the net force of each. Justify your answer. So, we can set these up as equations. So we know that there's a force of, or just say applied, is equal to mass times acceleration. This is how we set up our net force. Now we have force P. So technically we don't have an exact, we don't have it in newtons, but we could just say, what is it? 10 meters per second. However, because both blocks have constant speed, we know that acceleration is equal to 0. So they actually have the same exact net force of 0 because neither of them have acceleration. And that's question 4 for you. Question 5. A man ties a rope. So we're going to draw a man. We're going to draw a very nice rope. And we're going to draw a box. So a man ties a rope to a box and pulls a box across the floor with rope. And then have action and reaction pairs. So the box gets pulled by a rope. The box has an equal and opposite reaction that way. The rope gets pulled both this way from a box and pulled this way by the man. We could call this later force tension. And the man pulls the box this way and gets pulled back from the box this way. This can also be described as force tension. This can be described as force tension. And there we go. That's all. Real simple. And then if we want to focus on a single thing, so say we want to focus on a box, we can have gravity. Nope, that's force normal. This is force gravity. It has force of tension this way. And then we have the equal and opposite reaction that way. So technically, when we look at future problems, the rope is an internal force, but we don't have to worry about that right now. I'll get more into that as we continue on. Anyways, that's all for problem 5. Let's go into problem 6. Question 6. Shohei Ohtani throws a ball straight into the air at a speed of 40 meters per second. In the process, he moves his hand through a distance of 1.5 meters. If a ball has a mass of 1.5 kilograms, find the force he exerts on a ball to give it this upward speed. So, we can set this up as a force equation. Sum of forces is equal to force applied, which is Shohei Ohtani throwing the ball, is equal to mass times acceleration. We have a mass, but we don't have acceleration. So, to find acceleration, we could actually use kinematics on this. So over here. So we got separated our inventory, sorry. So our initial velocity is 0. Our final velocity, as in the question, is 40 meters per second. Now, initial velocity is 0 because when it's in his hand, the ball is not moving, obviously. And when we clock it, it's at 40. Our change in x is 1.5 meters. Our time is not given. And our acceleration is what we're looking for. So, whenever you're doing this kinematic equation, you need at least 3 variables to solve a problem, and to choose which equation you want to use. So, because we're looking for acceleration and we don't have time, we use without time equation, which is vf squared. Come on, vf squared is equal to vi squared plus 2 acceleration change in x. Yep. So now we're going to fill this out. 40 squared is equal to vi squared 0, so just 2 accelerations we're looking for. That's 1.5. 40 squared is 1600, so they equal to 3a divided by 3, We'll send this all the way, if I can find it, down here. Acceleration is equal to 533, is that correct? Yes, meters per second squared. Now we simply put this back into our system equations, or this one. So we have force pull, or applied, sorry, is equal to 0.15 kilograms. Now make sure, if you're doing any net force equations, that your mass is in kilograms, because if they give it to you in grams, you have to convert it to kilograms because these equations only work in kilograms. Just thought pointing that out there. And our acceleration of 533, meaning our applied force, Jesus, wow, this is not want to work right now, is equal to 80 newtons. There we go. That wasn't too bad. All right. That's it for question 6. Let's move on to question 7. Question 7 asks, a 4 kilogram block and a 2 kilogram block can move on a horizontal frictionless surface. The blocks are accelerated by a 12 Newton force that pushes the larger block against the smaller one. So I've done this question a couple times and I keep messing up on stupid parts. So we're going to do this fast. We're going to draw it out. Bam. Boop. We're going to say this is block A. This is block B. We're trying to see what block B does in block A. So draw a free diagram for block A. So we have the 12 Newton force going this way. And we have block B's force going that way. So we can set this up as force B is equal to mass times acceleration. However, we need to find acceleration before we can do this. So we're going to set this up as the net force of the entire system. So the net force of the entire system is equal to force applied. We're going to set that equal to the mass of the system. So M sum times A. Force applied, as said, is 12 newtons. M sum is equal to 4 plus 2, because that's the sum of all the blocks, times A. And we're going to solve by A if I did not say it before. So 12 is equal to 6A divided by 6, divided by 6. A is equal to 2. Now going back to over here, now we can say FB is equal to 4 times 2. No, sorry. That's for block A, sorry. So FB is equal to 2 times 2, meaning the force that block B applies in force on block A is equal to 4 newtons. Oh, and by the way, block B applies a force on block A because of Newton's third law, which states that every action has an equal and opposite reaction, meaning that when A pushes on B, B pushes back on A. Now, using that same law for question B, we know that because they have equal forces being applied, we know that block A also applies 4 newtons on block B. Also, a better way to visualize this, so we know that technically, if we want to find force of A, we could do force A is equal to mass times acceleration, so that'd be 4 times 2, which, I mean, you might be thinking, so force A should be 8 newtons. However, that's just 8 newtons going in this direction. But because we know that there's an opposite reaction pushing back on it, we should really set this up as 8 newtons to force of block A minus 4 newtons. So all in all, block A also has a force of 4 newtons. So here's the answer for part A and part B. Alright, that is the entire review for Unit 1. If you have any questions, please leave them in the comments down below. But other than that, I hope you guys have a great Halloween or whenever you're seeing this, and I'm out.